So I decided to take us to the beach, just kidding, in lab, of course. And we're gonna make a column, chromatography column out of this pipette. First thing I wanna do is break the tip off to make it a little bit shorter. And the way I'll do it is I'll score it on the edge of this bench. The way I do that is I just kind of rub it back and forth. Scoring it just means to like scratch it so that it breaks cleaner at the scratch. So let's see if I could do this one-handed. Boop. Yep, I broke it off. So see how it's much shorter now? The next thing I'll do is I'll put a little bit of cotton. I'm only gonna use about that much, not much at all. So that this just prevents the aluminum from falling out. My stationary phase will be aluminum. I'll show you that shortly. I've got my cotton in the end of it, and I just kind of use a long pipette to push it down in. Okay, got some cotton in there. That's going to stop the alumina from falling out the bottom. Next up, I add the alumina. Here's my alumina. It's activated. It means it was dried in an oven just to drive moisture off of it. There's different types of alumina. You can get acidic, basic, and neutral. So this is our alumina. It's a chromatography grade 80 to 325 mesh. That's how that tells you about the size of the beads. And then it's basic. pH 10% suspension. It'd be 9 to 10.5. So it's slightly basic. Okay, to get the alumina in the pipette, I'm just going to scoop it out of this. Take my pipette, scoop some of it up so it comes down to the bottom there. And then I just keep scooping. So I've got, it's mostly filled with alumina, and now I finish off with a little bit of sand on top to kind of protect the alumina. Just get a little bit in a spatula. Just drop it in like that. Go. We've got our column ready. Okay, I've set up my column on a ring stand with a 3-prong extension clamp, and I have it over just a waste speaker for now. And I've got my test tubes ready to go. I've got 10 of them. I don't know if I'll use all 10, but it's nice to have more than enough. And I've labeled them like this is test tube 1, and I put a line at about approximately 1 milliliter volume. That's about 1 centimeter wrap on this 13 by 100 millimeter test tube. So there's number 2, 3, so I'm ready to go there. And my column is dry right now. I'm gonna wet it, get it wet to get things started, and I'll do that with hexanes. I'll start with hexanes. So it's a very non-polar mixture of 6 carbon alkanes. So I'm gonna pipette some up, push it out, do that a few times. Let's drip a lot on me, and then I'll carefully add it to the top of the column. Get this column wet. You can focus as you can see that liquid going down. And I could do this addition and just be patient and let gravity do it for me, or I could speed it up, putting a little pressure on there. So I'm going to speed it up. As I was getting a pipette bowl, the hexanes drained through gravity. So I'll add some more, and I'll show you what I mean by using the pipette bowl. So once I've added my liquid, I could take a pipette bowl and I could put it on top, and I could squeeze it to make it go down fast. And then I gotta be careful. This will save you time. This is a great power I'm giving you, but with great power comes great responsibility. So you have to be careful. You don't want to push air through the column. So when I squeeze the bowl, when it's on top, I squeeze it. I want to stop before the liquid gets to the sand, right before it gets to the sand. And I also, after I squeeze it, I want to take it off the column, then unsqueeze it. If I have it on the column, I squeeze and I let go of the squeeze while it's still connected, it'll backflow, it'll suck solution up, it'll mix your sand and your silica, or not silica, alumina together. So here, watch, I'll squeeze. You can see it's coming out the bottom now too, it's dripping. So I usually put 2-3 milliliters. I just went through just the non-polar hexanes to begin with, to get things started. And I don't need to collect any of this solution in the test tubes because I know this is before I've added my molecules to be separated. So I'm going to do it again. Squeeze, take it off, release the squeeze. I think that's enough. I think my pipette chromatography column is ready to be moved into test tube number 1. So I'll rise it up, scoot number 1 over. There we go. And I'm going to start this off, this runoff, by adding my mixture of fluorine and fluorinone. And this is part D. And I'm going to add about 0.3 milliliters, and that winds up being about 18 drops from this is a dropper bottle in there. And this is a 3% solution, 3% fluorine, 3% fluorinone in solvent that's mostly hexanes, but it's 5% methylene chloride, 95% hexanes. 3% means I dissolved 3 grams of each of the solids in a solution that's 100 milliliters. All right, here we go. Let's see how many drops. 18 drops. Let's see if I can do that. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay. So I've added my mixture with my 2 compounds, the fluorine and the fluorinone. And I could use a great power here. I can get that in a little faster by putting a little bit of pressure and stopping before it gets to the sand. Okay. Now I've got my 2 compounds on there, and I'm going to be watching the test tube at the bottom, the volume. So number 1, you can see, I think you can see it's not quite to the line. When it gets to that line, or about right to that 1 milliliter line, then I'm going to go and slide over and go into test tube 2, and then 3, 4. I'm going to start this off with just hexanes. Run some hexanes through there. I'm going to use about 3 milliliters of just hexanes. Now to add the hexanes, I'll just drip it in the top here. I like to just fill up the top and then use the bulb to speed it up. With great power comes great responsibility. I got to pull that off and now release it. More hexanes. And while I'm doing this, I'll look down on my volume. I'm not quite at a milliliter for number 1 yet, so I can keep going. You can see the yellow fluorinones already starting to go down through the alumina stationary phase a little bit. There we go. And add some more. Let's see, where are we at? Oh, I think we're ready to switch to test tube 2. Chink. Now we're in test tube 2. And almost out of the hexane. We're starting with just non-polar hexane at the start of this. And number 2 is almost full now too. Seems like my test tubes might be more than a milliliter volume, because if I'm adding 3 milliliters of hexanes, I should be at the 3rd test tube by the time it's full. But okay, I'm going to switch to 3. There we go. Maybe I'm actually, yeah, it's probably just a little more than a milliliter each test tube. It doesn't really matter the volume that much. Okay, so push this last of the hexane in here. And now I'm going to take and add some more polars. I'm going to add 70% hexanes plus 30% acetone. So acetone's more polar. And I already made up this solution. I just added actually, I added 3.5 milliliters of hexanes and 1.5 milliliter of acetone to make the 70-30 mixture. I'm going to add a total of like 3 milliliters of this as well. Okay, now to start with the 70-30. 70% hexanes, 30% more polar acetone. Let's see, at number 3 we are got a little bit more volume to go. Okay, I'll call test tube 3 full, fluor 4. You can see that yellow really coming through now, huh? Increasing to that 30% acetone got the fluorinone to move a little faster. 4 is almost at its line. Pause there, and I'll switch it over to 5. Oops, I might have missed the drop. That was a bad switch. Not too big of a deal though. Okay, now I'm going to end off with a straight acetone. So now into 6 with straight acetone, the most polar of the solvents, 100% acetone. We saw acetone was very polar on TLC. We use it to clean our TLC plates. Pushes all the spots to the top because of its polarity. Okay, 6 looks full. I'll go to 7. Now to 8. And we're done. Now I will see what happened. I'm going to spot these on a TLC plate and have also a reference of the fluorinone as a spot, because I could do fluorinone and fluorine. I'll do both of those reference, and then I'll have a TLC spot of test tube 1, 2, 3, 4. We'll see how well our separation works. I'm going to run my TLC plates in a methylene chloride chamber. I put the wick in there and I tore off the sides. I'm going to do 2 TLC plates at once. This is going to be the fluorine spot, which I prepared by putting a pinch of fluorine in the test tube, followed by some methylene chloride. And then the O is with the fluorinone. I took a pinch of fluorinone and dissolved it in methylene chloride. And then the 1, 2, 3, 4 will be test tubes 1, 2, 3, 4 from the collection of the column chromatography. And then over here on the next TLC plate, I got the standards again, E and O, and the test tubes 5, 6, 7, 8. So let me prepare my methylene chloride chamber by adding methylene chloride. Let's just pipette some methylene chloride down the wick into the bottom of the beaker and fill the beaker up so it's just coating the bottom of the beaker and allowing me to place my TLC plates in there and have my spots above the solvent level to begin with. Almost there. This is a little bigger beaker than I used before, but I think it's going to work out fine. Yeah, that looks good. Then I'll put a watch glass on top. Let's see if this is a good size. Yeah, that'll work. Okay, now to spot my samples. And just a reminder, so we have the fluorine, that is the less polar of the two. That's the one with the 2 benzene rings attached with the 5-membered ring. And no oxygens. That's the fluorine. E I have labeled on my TLC plate. And then I have the ON, which is the ketone version. This will be more polar because it has that ketone that can hydrogen bond to the silica. Oh, this is alumina. Oh no, this is silica still. Yeah. The TLC plate silica, the column was alumina. So here we go, yeah. So as it's traveling up the TLC plate, it's going to be slower, right? Because it's going to hydrogen bond where this one can't. So let's spot these. I'll take my capillary tube. I still got some from when I first made them, and I'm going to go in first. So stick that in my solution, and it gets me a lot initially. And I'll drain that out on a piece of paper towel. And then I can spot that on the TLC plate. There it is, one, this one as well. Got it. Break off that tip, put it in the waste beaker, Get my fluorine standard. Bring it over, drain most of it. Spot, oh wait, fluorine. I mixed them up, didn't I? Fluorinone, huh. Okay, I got that. Okay, I did these, spotted these backward, but it's fine. I realized it in time. So this is the own. This is the ene. So they're backwards. Own, because it's yellow and you can tell ene. All right, now it's time to spot my test tubes. So here they are, the test tubes from the column chromatography. I'm going to go into test tube 1, draw some of it up, drain most of it, and then spot it on number 1. I'm going to spot it multiple times. There's 1, I'm going to let it dry. 2, 3, 4. I'll do it 4 times. I believe there's going to be nothing in test tube 1 because test tube 1 was at the very beginning of the run where just hexane was going through, and it takes a little while for the molecules to get through the column. So I'm assuming there's nothing there. So I broke off my tip, got dipped into test tube 2, so now I'm going to do 2. Spot that a bunch of times. 1, 2, 3, 4, 5, 6. Okay, that's good. And now on to test tube 3. Now 4. I'm curious to see what these look like before I run them. I'm going to bring it to the UV light box. I'll go with my trusty 254 nanometer ultraviolet light and look inside of here. So it looks like test tube 1 had nothing in it like I expected. 2, 3, 4 all have a little bit. Now let's continue on to 5 and the rest. 5, you can see the yellow. Looks like it has fluorinone for sure, huh? 6, not so yellow. So 6 might have just a little bit of the last bit of the fluorinone or nothing. Number 8, the last one. Okay, let's see how they look before we run them, develop them. Yes, it looks like 5 has some molecules, 6, 7, 8, not much. Now to carefully place them in the TLC chamber. And yes, the solvent started below the spots. I'm happy with that placement. See if I can get this one to look good too. Yes, looks good. Solvent's traveling up, if you can see. Now I'll take the TLC plates out and mark their solvent fronts immediately. Yeah, there we go. Maybe a little bit high on that one. Okay, let those evaporate. I mean, evaporate. Let the solvents evaporate off of them, the methylene chloride. And look at them under the UV lamp. Shake, shake, shake. Shake, 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 shake your booty. Ow, shake your booty. 254 nanometers. Ooh, there we go. Interesting. What's going on here? Let's look at this. So fluorine is the fluorinone is the lower spot at the top there, and then fluorine's higher. And test tube 1 looks like it has nothing. 2 looks like it has fluorine. 3 has fluorine. 4 has just fluorinone, maybe, huh? So it looks like it separated out well. So if I took test tube 2 and 3 and I evaporated the solvents from them, I should have pure fluorine. Nice. I'm going to circle these.
Here's the second TLC plate. You can see the fluorinone, fluorine standards, and then test tube 5 has just fluorinone. 6, 7, 8 have nothing. So it looks like I think it's 4 and 5 test tubes. If I took those two, dumped them into like a beaker and just let their solvents evaporate, I'd have pure fluorinone. Nice.